Hello, geometry and advanced geometry students. Hope you guys are all staying healthy, busy, that you're not too sick of your family members yet, and they're not too sick of you, but who knows. We are going to do our best here to try to communicate a lesson on right triangle trigonometry, which means using sine, cosine, and tangent to solve for missing sides. You can also use these to find angles. We're going to do that after the April break. We're just going to try to get through using sine, cosine, and tangent to find missing sides, okay? It sounds kind of crazy. Trigonometry, yikes, big word. It's not very difficult. Please trust me on that one. So we're going to jump in here. And the reason why we can use these functions, sine, cosine, and tangent, is that any similar triangles, when that angle is the same, the ratio of all the sides is the same, okay? That's not a whole too important. What matters is how to use it, and that's what I'm going to try to show you here, okay? So the three trig ratios that we use in geometry most of the time are sine, cosine, and tangent. This diagram here is a little confusing, so I'll simplify it in a little bit coming up. The reason why it is useful is the same reason why we talk about the Pythagorean theorem and other shortcuts that we have. It's a way to find missing sides and angles of right triangles. Okay, so let's give it a shot here. We're going to take this right triangle here and we're going to solve for x. So what we need to figure out is what we have. If you position yourself at 41 degrees, x is the opposite side, right? It's across from 41, so we call it the opposite side, which I'm going to abbreviate OPB. 7 is next to 41 degrees, so it's the adjacent side. Adjacent means next to. I don't think I spelled it right there. There's no S, just for the record. And of course, the hypotenuse, which you already knew, is the long side of a right triangle. Well, we don't really need that one in this case, do we? So the only information that we have and need is the opposite and the adjacent. So what we then want to ask ourselves is which one of those trig ratios use opposite and adjacent. So we go back to this diagram. Let's see. I see this one tangent is the opposite and adjacent. Okay. So to review, we've got a very useful phrase called SohCahToa, and it's a way that we can remember what sine, cosine, and tangent mean. Okay. Sine is the opposite over hypotenuse. So if I just remember so, I can remember that sine equals the opposite over hypotenuse. Ka stands for cosine equals the adjacent over the hypotenuse. And tangent, TOA, helps us remember that tangent equals the opposite over adjacent. Okay? So again, when we put this into use, I think you'll see that it's not that difficult. Here's a little bit of an easier way we can look at it. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. We have this funny symbol here. It's called theta. It's just a Greek letter that we typically use for angles. We ran out of letters in the alphabet to start using Greek letters. I know it sounds crazy, but that's just what we do. We use theta for angles. Okay, I don't know what that 1.7's doing there. So, again, we've got the opposite side is what we want to find. We know the adjacent side. So, it's okay. We've got the opposite. We've got the adjacent. So we're going to use tangent. Tangent equals opposite over adjacent. So I plug in for theta, 41 degrees. I plug in for the opposite x. And I plug in for the adjacent 7. And then it simply becomes an algebra problem. In order to undo dividing by 7, what do you have to do? You multiply both sides by 7. And 7 tan 41 is what I can literally put into the calculator. Okay, I also would need to make sure my calculator is in the right mode. If you hit mode on your calculator, there's two options here, radian and degree. Radian is some kind of more confusing way that we refer to angles and rotations. So in this case, we'll just be using degrees. But you always want to make sure your calculator is in the degree mode. But like we said down here, we've got 7 tan 41 will get us our answer. I just hit right into the calculator, 7 tan 41. You don't even have to close the parentheses necessarily. Typically, I'll round to the nearest hundredth, so we get 6.09 for x there. Let's do a few more. So I look at my triangle. I try to see the information that I've got. 11 is my hypotenuse. X is my adjacent. Okay, so I've tried to remember which one of those is adjacent and hypotenuse. Cosine uses adjacent and hypotenuse. Okay, so we've got hypotenuse, adjacent. We're going to write that cosine of theta equals the adjacent over hypotenuse. So plug in everything that you know. We know that theta is 56, the adjacent is x, the hypotenuse is 11. So it's just an algebra problem at this point. To undo dividing by 11, I multiply both sides by 11. And I can directly put that into the calculator. 11 cosine 56, just like that. And we get 6.15 feet. Don't forget the units. Okay, so again, this is our useful notes here. These are the three trig functions. We'll do a couple more together here. We'll do this last one, and then I'll give you two to work on your own. Okay, so again, we're going to label our sides. 14 is the opposite. The hypotenuse is C. Which one uses opposite and hypotenuse? That would be sine. Okay, and you can see that in this diagram. Sine uses opposite and hypotenuse. So I start by just writing that sine of theta equals the opposite over hypotenuse, and then plug in what you know or what you need to find. Theta is 67 degrees, the opposite is 14, the hypotenuse is C. And then I can get C by itself by swapping C with sine 67. Remember when we have a proportion like this, we learned that the numerator on one side, I can always switch with the denominator on another, right? I could just switch B and C if I want. And that's exactly, I gotta click a bunch of stuff here, but that's exactly what happened here. Okay, C is on the bottom, so I just swapped C in sine 67, and now C is by itself. 14 over sine 67 is exactly what I can put into the calculator. And we get 15.21. Here's what it looks like in the calculator. Oops, apologize. Nope, I don't have a screenshot of that. But you can just do 15 divided by, 14 divided by sine 67 directly into the calculator, and it should give you 15.21. Okay, so I'm going to pause it here, or at least I'd like you to pause it, and do your best to solve for x, look at your notes, try to set up the right proportions based on the sides you have, label those sides, go ahead and work on those, and when you're done solving, you can resume this video. Okay, so hopefully that went all right. Well, I label my side there, I've got x has the opposite side, 7 as the adjacent. So I say which one uses opposite and adjacent? That would be tangent. So I fill in all the information I've got. I can multiply both sides by 7, and I get 7 times tan 31, so that's 4.21. There's 7 tan 31, 4.21. Problem 2, I label the sides that I've got. 12 is my, I'm sorry, 12 is not the opposite side. 12 is the adjacent side. So I've got adjacent and hypotenuse. It means I need to use, sorry about this, cosine. Cosine of theta is adjacent over hypotenuse. So plug in what you've got. The theta is 28, the adjacent is 12, the hypotenuse is x. This is one of those where x is on the bottom, no big deal. Swap x with cosine of 28, and it's 12 divided by cosine of 28. As we see here, you can put that directly into the calculator as that. We're going to get 13.59. Okay, and another thing to check, we know how long the sides need to be compared to each other, meaning the hypotenuse always has to be the longest one, so it's good that our answer was longer than 12. Things to think about as you're solving. So there's going to be an online Pearson assignment. Look for that in Pearson. It's only going to be using sine, cosine, and tangent. Solve for missing sides. There's tons of information out there on this. I hope it goes well. Later in the week, we'll be having Zoom sessions where you can ask me questions directly. I'll send out communication on that. Hang in there. One more week. You guys got a break. So let's just hold it steady to the finish line. Hope you guys are doing well and healthy. Bye-bye.